Okay, folks, up until this point we've been mostly graphing straight lines. Every motion has had its own separate line to represent the separate motions, and that's not always the case. Objects have different, can change their speed, and so we've been looking at things like walking and what happens if the object stops. You know that the object stops because look at time is passing. This is about 2.5 seconds have passed, but yet there's no distance gained. So when time passes but no distance gains, you have a stop. And then the same thing goes true with the slope or the steepness of the line. If the line is steeper, the object is moving faster. Sometimes you have situations where, in this case, you've got to walk fast, you've got another stop, but then the object maybe turns around and comes back to the starting line. So they go all the way to the end, they stop, and they turn right back around. But in this case, they're going at a little bit different speed. Again, it's steeper. This is what we call a negative slope. I'm going to talk more about that in a little bit. So what is the speed for each one of these? Well, we know that speed, velocity, is distance divided by time. So up until this point, we've just picked a point and calculated the speed, but we've got to be very, very careful on this because there's going to be some problems that I'm going to show you. So if you see down here, I've got 1 point on the walk. If we figure out the coordinates 2 and 2, and we divide that out, distance divided by time gives us 1 meter per second. Okay, that's fine. That makes sense, and so far. We're going to jump up here to run. I'm skipping this for a reason. So we got a point. There's the coordinates. We calculate the speed. Okay, that's interesting. It's definitely more than the walk. Not much more, but yet looks a little steeper. I would have estimated a lot more than just 1.2 meters per second. Okay, let's see what the stop looks like. Okay, there's our point. There's our coordinates. Whoa, something is really weird here. So if I'm stopped, how could I have something greater or anything but 0? So stationary objects don't have anything but 0 for their speed. That's because we have, what we just did was called average speed. So it's the average of all the motions. So let me explain. There's our 3 points. The average speed was 1 meter per second. That first motion does not have any other motions before it, so the average speed is going to be exactly what it is. It's not going to be interfered by anything that came before it other than what it's been doing. So it takes into consideration all of the data, all of the motion that came before it. Okay, that one's easy. Let's see what happened with the stop. The average speed was 0.75 meters per second. That's because the second motion point takes into consideration everything that came before it. So everything in that red line, or that red circle, whatever you want to call it, red object, is it's all the data that came before it, all the motion. So you have walks in there, you have some stops before you get to this point. So it's an average. You add up all of those points, you know, the infinite number of points between 0 and the stop point here, and you're going to end up with the average between them, which happens to be 0.75. If we go a little further down here and we put a point, this would drop down because we'd have more zeros. If we put this up here, this average speed would actually increase because we're taking away zeros by doing that. Okay. Now the run, it definitely should have been higher than 1.2 meters per second. That third motion again takes into consideration all the walks, all the walking that occurred, all the stopping that occurred, and then all the runs up until that point right there. So it takes into consideration all of those, infinite number of points in between there, and averages them out. Okay. So a lot of times we want to know what the actual speed of the object is traveling, or the rate at which it's changing its distance. And so we've got to walk there. Its average speed was 1 meter per second. The actual speed it was going at was 1 meter per second, because the average and the instantaneous in this case is the same, because there was nothing, no motion, no different type of motion prior to starting. If we look at our stop, the average speed is 5 meters per second. The instantaneous speed, we know that that's stopping. It's a horizontal line. We can indicate just by knowing there's no distance gained over that time. It's definitely going 0 meters per second. That now makes sense. Now the run. The average speed is 1.2 meters per second. For those of you that are interested, I would pause the video and I would estimate what do you think it is. Don't try to calculate it here or do anything fancy. Just roughly estimate it based on the angle of the line. The answer is 3.5 meters per second. That makes a lot more sense. It's, you know, roughly 3 times, maybe a little more than that, because the angle is approximately 3 times greater. So now the question is how did we get those instantaneous speeds or velocities? Mathematically, the steepness of the line is what we call the slope of the line. The greater the slope, the greater the speed. So how do we calculate that? Or first of all, what is slope? It's the steepness of the line. Okay. Look at this diagram right here. This is what's called the rise. Rise going up, run going across. This is the x, this is the y. We're looking at the change in the y. So how much does it go up? How much does it go across? This m right here, that means slope. It's often abbreviated as this symbol right here is called delta. This triangle means change. So we're looking at the change in y divided by the change in x. Here's how it breaks down. All we're doing is dividing the rise, the y, change in y, over the change of x, the rise divided by the run. How do we figure that out? Well, you just need to look at 2 points. y2 would be up here, y1 is down here, so you subtract them. x2, this is x2, that's x1. Just think about it, the one that came first is x1, the one that came second is x2. So if we use that equation and we look at 2 points on a graph, so you need 2 points. You can't do this with one, or else you're just finding the average velocity. Now in the case of the first line, because there's no motion prior to the first line here, the first slope, then the average and the instantaneous are going to be the same. But for purposes of trying to do this, there's your 2 points. Just take your y's, 2.5, your change in y